The force between any 2 point charges. F is equals to 1 by 4 pi epsilon naught Q1 Q2 by your R square. Isn't it? Value of 1 by 4 pi epsilon naught is how much better? 9 into 10 to the power of your 9. And relative permeability is ratio of your permittivity of medium divided by the permittivity of air or vacuum. That is represented by K. Okay. It is conservative in nature, as also I told you, and it obeys the principle of superposition. So we can apply the vector addition formula. Fr is equal to under root of Fn square plus F2 square plus 2Fn F2 into cos theta. Theta is the angle between the two forces F1 and as well as of your F2. If I need to calculate the direction, that is alpha, tan alpha is equal to F2 sin theta divided by F1 plus F2 into your cos theta.
Yes, sir.
Isn't it? Now let us try to go for the today's track, that is applications of the Coulombs law. Applications of your Coulombs law part of relation. See this one better. What you have done today in the college, beta?
Sir, today we did at different angles the force acting and at equilibrium and everything.
Okay, fine.
Yes.
Sure. See this application, beta. Listen very carefully and try to see. We got two identical spheres. We got two identical spheres which are having positive charges. Positive charges placed 3 meters apart. Placed 3 meters apart. They repel each other. Repel each other with a force of 8 into 10 to the power of minus 3 Newton. Okay. Now, charges have been connected. Charges are connected by a metallic wire. This is something very important. Connected by a metallic wire. So what happens? They begin to repel each other with a force of 9 into 10 to the power of minus 3 Newton. Okay, find the initial charges on the sphere. Find the initial charges on your sphere. So first try to understand the question carefully better. We have got two identical spheres having the positive charges. Both of them are positive. Obviously, they will be repelling each other. Yes. And initially, they are being kept at a distance of what meter? 3 meters apart. And they are repelling each other with a force of 8 into 10 to the power of minus 3 Newton. Now, the charges are connected by the metallic wire. The moment you are connecting it by a metallic wire, they begin to repel with a new force of 9 into 10 to the power of minus 3 Newton.
Yes.
What is the initial charges on the spheres? What is the initial charges on the spheres part of relation? Is that clear?
Yes, sir.
Don't know what are the initial charges on this one, better. Let us try to assume that initially we are having a charge here right now Q1, and this is separated by a distance of here. This one is right now Q2, and this is separated by a distance of your R is equals to how much better? 3 meters. Okay, so this is the separation between both the charges. They are repelling means both of them should be of what nature? Same nature, that is positive and as well as of your positive. So what is the force existing between them, beta? F is equals to your, I can write this one as 1 by 4 pi epsilon naught into your Q1 into Q2 divided by your R square. Force between them better when they are at a distance of 3 meters, we are having a force of your 8 into 10 to the power of minus 3. And you know the 1
Yes,
by
sir.
4 pi epsilon naught value is 9 into 10 to the
To the
power of
power
9
of 9
into charges right now q1 into q2 divided by r is equals to how
is
much for
square.
me? 3 meters. That is nothing but 3
3
square.
square. Yes.
Square is nothing but 9. So this 9 and this 9
Yes, sir.
will cancel, isn't it?
Yes, sir.
From this one I can get the value of q1 and q2. So q1 and q2 will be equal to, this will be your 8 into 10 to the power of this 9. If it goes here, that will become for me minus 9, minus 9, 10, 11, 12. This will become for me minus 12. Is it clear?
Yes, sir.
So q1 and q2 initially is how much right now for me beta? q1 and q2 is equals to 8 into 10 to the power of your minus of your two-part relation. Clear?
Yes, sir.
Chalo. Now see. Now what is happening is, now what is happening? Now the charges are being connected by what? Metallic wire. So what do you mean by that one beta? In second case, this is the same charge q1 and this one is also your same charge of your q2. Both of them are positive and both of them are positive. Now they are connected by a conducting wire. This is some conducting wire, right? Role of the conducting wire is that the moment you connect it by a conducting wire, there will be the flow of the charges from higher potential to lower potential, or from higher charge to lower charge, till they become equilibrium, Now see, at that time I can write the force between them is right now F dash, so that is equals to 1 by 4 pi into your epsilon or naught. Is it clear here right now?
Yes, sir.
Isn't it? Now what will be the charges on this one? The new charges, see, when q1 and q2 are being connected right now with a metallic wire, they'll share the charges till they become equilibrium. The distance between them is no doubt still it is your 3 meters, isn't it? Now this one
Yes,
charges
sir.
on this one will be equal to how much after connecting? They will change. That is q1 dash and q2 dash. So what is that q1 dash beta? After charging, q1 dash will be equal to, they will be equally shared, but it will be q1 plus of your q2 divided by 2, and q2 dash will also will be equal to your q1 plus of your q2 divided by 2. Because I
Okay,
don't
sir.
know how much is the q1 and q2, that is the reason they are equally getting distributed. So if I know
Okay.
q1 plus q2, if I divide it by 2, I'll get the value of q1 dash and q2 dash,
Yes, sir.
isn't it? Now I can write here right now, in this given condition, this will be equal to your q1 dash and this one will be your q2 dash divided by your r square. Distance between them is not going to change, but force has been changed. What is the force we are taken right now? 9 into 10 to the power of minus 3. Before connecting it was 8 into 10 to the power of minus 3. After connecting by conducting wire, it is 9 into 10 to the power of minus 3. And 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. q1 dash and q2 dash is same, so I can take here q1 plus of your q2 divided by 2. This one is whole square divided by your 3 square divided by your 3 square. Is it clear?
Yes, sir. So what means, like, if we do divided by 2, q1 plus q2 divided by 2, sir, they have not mentioned anywhere.
Is better?
Sir, once can you just show the question, sir? I just had one.
Yeah. Now what is asking? Initial charges on the space is asking.
Yes, sir. So, ante, what is the reason that we are for Q1 and Q2 dash? Why are we doing Q1 plus Q2 by 2, sir?
Why we are doing q1 plus q2 means here. Now the charges are being connected by, they are connected by a metallic wire. Whenever
Yes, sir.
the two bodies are connected by a metallic wire beta, the charges on each of them will become for me equal. That is q1 plus q2 divided by 2.
Okay, okay, sir.
Got it? Like say for
Yeah.
example, you're only the kid to your parents. Like say
Yes, sir.
every festival, your father or mother on your festival is giving, like say an happy, in a form of an happiness, and during Diwali, they might be bringing you the sweets or maybe the what do you call that one, crackers, or maybe gifting you something. When you are a
Yes, sir.
single child, now the moment you have got a brother and sister, now after certain time, they you might be been getting the same thing divided equally between both of you right now,
Yes, sir.
isn't it?
Okay, that's why Q1 plus Q2 divided by 2 is the
An
same.
equal distribution whenever two bodies are connected by your connecting wire,
Okay, sir. Yeah, got it, sir.
isn't it?
Yes,
Like
sir.
say if your brother and if your cousin, isn't it? See, for example, your cousin may not get as much as love and affection as your dad may be doing to you.
Okay,
Maybe
sir.
even a 5% lesser than, greater than your cousin. isn't it? Maybe
Okay,
5%
sir.
or
Yes,
10% greater, but not equal. But if he
yes,
or she is your exactly an half spring, I mean to say your blood sister, then the love between both of you will be always be a same.
equal, same. Yes, sir.
So whenever two bodies are connected by same connecting wire, isn't it? So they will be
Yes, sir.
equally distribution of a charges. That is the reason I'm taking it as of your Q1 plus Q2 divided by 2 part definition.
Yes, sir.
Now can I simplify this one better? So if I'm going for the simplification of this one, so I can get right now from this one. Sorry, this I'll take the pen here. Yeah, this here anything is getting cancelled. This one and this one will get cancelled. This will
Yes,
come
sir.
here right now. So that will become how much for me, beta? That will become for me. This will become for me square. That is nothing but equal to your 4. That means this will become for me Q1 plus of your Q2 divided by 2. I'll take whole square here right now. This will be how much, beta? 9 into
9
10 to
into
the
10 to the
power of
power of
minus.
minus 3.
Hmm.
Into this will come here, means it will go up minus
Minus
9.
12.
Minus 12. Minus 12. Sir.
Minus 12.
Yes, sir.
Now, what is the
Yes.
value of Q1 plus of your Q2 right now?
A.
Q1 plus of your Q2 whole square divided by 4 is equals to 9 into 10 to the power of minus 12. So if I take only Q1 plus Q2, so Q1 plus of your Q2 will be equal to, that will be equal to how much, better? If I do the square root here, this will become for me 3 and here it will become for me 2. So it will
2.
be equal to how
Yes.
much for me, better? 3 into 2, that will become for me 6.
6.
6
Yes.
into 10 to the power of minus 12 half, that will become for me minus 6.
Yes, sir.
Isn't it? So now you
Yes,
got
sir.
the value of Q1 plus Q2 and you got here Q1 into Q2.
Q1 into Q2.
And we know the basic mathematics here right now. We know the basic mathematics that from basic mathematics, from your basic maths, this maths you should remember. I hope you might have been already known it, but still I am writing
Yes,
here
sir.
right now. It is your A minus of your B whole square will be equal to A plus of B whole square minus 4 times of A1 into A2. Isn't it? So this
Okay,
is
yes,
the
sir.
basic
Yes,
maths
sir.
you should be knowing right now. Isn't it? So this one
Yes.
is A minus B whole square will be equal to your A plus B whole square minus of your 4 into your A1 into your A2 part. Now I know A1 plus A2 is nothing but here A is Q1 and B is your Q2. Is that clear? So I can write here
Yes,
Q1
sir.
minus of your Q2. Q1 minus of your Q2 whole square is equals to, I can write this one as Q1 plus of your Q2 whole square minus 4 times of your Q1 into Q2. Isn't it? Q1 plus Q2 is known for me, beta. How much it is? 6 into 10 to the power of minus 6 whole square minus 4 into Q1 into Q2 is how much we got, beta? Q1 into Q2 is 8 into 10 to the power of minus of your 12. This one. Q1 into Q2 is equals to 8 into 10 to the power of your minus 12. So from this one, you see how much I'll be getting, beta? 6 is 36 into 10 to the power of minus 12
Minus 12.
4 8 is
32, sir.
32 into 10 to the power of minus 12.
Minus 12.
That means how much this will become for me? 36 minus 32.
4, sir.
Huh?
4, sir.
4. So that one
Yes,
is
sir.
4 into 10 to the power of minus 12. So
Yes,
that
sir.
means a Q1 minus of Q2 whole square. So what will be the Q1 minus Q2? Q1 minus of Q2
Under,
will become for me how much? 2 into
under root
10
of.
to the power of minus 6.
Yes, sir. 212 minus 6.
Ante kada?
Yes, sir.
So this one is my equation number 3. Q1 plus Q2, what I got right now, this is my equation number 2. So I know Q1 and Q2, I know Q1 plus Q2. So I can calculate individually Q1 and Q2 better from equation 2 and 3. From 2 and 3. Isn't it? So what I can write now here, beta, Q1 minus Q2 is this much and Q1 plus Q2 is 6 into 10 to the power of minus 6. Can you get me what is the value of Q1 and beta from this one?
Yes, sir. Because we have Q1 plus Q2 and Q1 minus Q2, sir. Both of them we have.
See how much I'll be getting. What I can do?
So we can,
what I can do?
sir, we can subtract, sir.
We can subtract or we can add.
Sir, it is 6 only, right, sir? So we have to subtract.
Q1 minus Q2 and Q1 plus Q2.
Yes, sir. We have to subtract only, right, sir?
Okay, so let us try to subtract from equation 2. Let's see. Subtract 2 from your 1.
No, wait, sir.
So it is a
Q1 plus
Q1
Q2.
plus Q2 minus of your, what is this one?
Sir, no,
Q1
sir.
minus Q2.
Yes, sir.
So this will become how much?
No, sir.
Minus.
Yes, sir. Look on plus again.
So this will get cancelled. What get cancelled here right now? This is plus and this is minus, na? Q1 and
Sir,
Q2.
we'll get Q1, sir. Yeah, Q1 will get
So
cancelled and
this
we'll get
is a
Q2.
plus and this is minus. This will become for me how much? 2 times of Q2.
Yes, sir. We'll get that, sir.
Isn't it?
And
Now,
once we get
Q1
Q2
plus Q2
value,
is how much we got, beta? Q1 plus Q2 is how much
6
we got?
into 10 to the 6 into 10 to the power of
Q1 plus Q2
minus.
is 6. Yeah.
Yes,
6
sir.
into 10 to the power of minus 6. This one
Minus.
is 2 into 10 to the power of minus 6. That
Yes.
means 6 minus 2, this will be equal to how much? 4.
4 into 10
into
to
10 to the power of minus 6. So Q2
yes, sir.
will
2
be
will come here, 2
2
ones.
2 2s are. So it is a
Yes.
2 into 10 to the power of minus 6 is Q2.
Yes, sir.
So that means 10 to the power of minus 6 means what? Micro. So Q2
Yes,
will
sir.
be equal to how much for me? 2 microcoulombs.
Okay,
Yeah.
sir. Yes.
Now I know the value of Q2. So can I get the value of Q1 from any equation?
Yes, sir. We can get it, sir.
From Q1 plus Q2 is equals to how much it is? 6 into 10 to the power of
10 to the
minus
power
6.
of minus 6.
This one I can get Q1 plus this one is 2 into 10 to the power of minus 6. That is equals to 6 into 10 to the power of minus 6. So how much I'll
4
be
into 10 to the power of minus.
So Q1 will become how much for me, beta? 4 into 10 to the power of minus, because 2 will go here, 6 minus 2, that is 4.
Yes, sir.
That means
Yes, sir.
Q1 will become how much for me, beta? 4 microcoulomb. As I'm doing on the board, I'm taking that much of a time. But when you do the calculation, you should skip a lot of things in this one.
Yes, sir. Yes, sir. Mentally, we can.
Mentally, you can do a lot of things, isn't it?
Yes, sir. Yes, sir.
So I hope you got such type of equations. Whenever metallic wires are being connected by some wire. So what you will try to do, you share the charges on that one, and the sharing of the charges is how much? Q1 plus Q2 divided by 2 each.
Yes, sir.
Is there any doubt in this one?
No, sir. Got it, sir.
Clear?
Yes, sir. Clear, sir.
Sure. Let me do one more question right now. Find the net electric force on charge Q in the following cases. And what you do is take 1 by 4 pi epsilon naught into capital Q small q divided by d square is equals to some f naught for calculation purposes. Okay. First question in this one. Okay, so this is the system which has given for me, and I have got a charges here, beta. One charge is here right now, Q. Another charge is kept here right now, say for example 16 times of capital Q. Another charge is being kept here, this is 9 times of capital Q. This distance is given for me as equals to 4D, and this distance is given as of your 3D. Is it clear?
Yes, sir.
So this is 3D, this is 4D. What will be this distance, beta? Another side. You can tell me.
Pythagoras we can use, sir.
Pythagoras theorem, under root of 3 square plus
Yes, sir.
that give me how much? 3 square is 9, 4 square is 16. So it is 16 plus 9.
25. Sir, 5D.
50.
Yes, sir.
Isn't it? Is it clear?
Yes, sir.
Now see the question. Find the net electric force on the charge what with a small q. That means we should take the small q as of your reference. You try to remember such type of your models better. Now what you'll do here? We'll try to take the small q as of your reference, and all of them are positive. Okay?
Okay, sir.
Are you getting my point? Small q
Yes,
is my
sir.
reference. That means so hide it.
It's the, yes, sir.
Capital 16q will exert the force on small q, and 9q will also exert the force on your small q. Not all how
Yes,
it
sir.
will be Okay, 16q will exert the force acting on this one, beta. This is the force exerted by your 16q. This is the force exerted by your 16q, and 9q will also exert the force on this one. So this is the force exerted by your 9q on this one in this direction. Do you agree? Why?
Yes, sir. Because both of them are acting on it, right?
Both of them are positive, but 16 is more.
Yes, sir. That's
there
why.
is more force on your small q in this direction.
Yes,
9
sir.
is more than this one, so that is in the downward direction. Is that clear?
Yes. Yes, sir. Yes, sir.
Now let us try to calculate the first force right now. Force between capital 16q and as of your small q. That is nothing but of your, this I am taking it as of your F1, and this I am taking it as of your F2. Any problem?
No, sir.
Now let us try to calculate the value of F1. So tell me what is F1? F1 is equals to 1 by 4 pi epsilon naught into Q1 is small q, another one is nothing but 16 times of capital Q divided by,
Yes.
this one is of your 4d whole square.
Yes, sir.
So that will become how much for me, beta? 1 by 4 pi epsilon naught into, this is 16 times of capital Q small q divided by 4 square is also 16, and this one is of your d square. Anything is getting cancelled, 16 and 16 will get
16.
cancelled. So this
Yes.
is coming out for me 1 by 4 pi epsilon naught into capital Q small q divided by d square. Already in the problem he told that whenever 1 by 4 pi epsilon naught, this is epsilon naught, capital Q small q by d square is coming, you try to take it as of your f naught. So f1 value is how much, beta? F naught.
Yes, sir.
Now tell me the value of your f2, beta. Right, tell me the value of f2. Can you tell me? F2 will be equal to how much, beta? Again 1 by 4 pi epsilon naught into, this is the force between 9q and small q. So this is 9q, and as well as of your small q divided by distance between them. That is nothing but of your 3d whole square. So that will
Yes,
be
sir.
equal to your how much for me? 1 by 4 pi into your epsilon naught into, this is 9 capital Q small q divided by, this one is 9 into your d square. Again in this one 9 and 9 is getting cancelled. So that will be equal to 1 by 4 pi epsilon naught into capital Q small q by d square. Again this one is nothing but equal to your f. So f2 is equal to how much for me? F naught. Agreed?
Yes, sir.
Now both of them are same na, beta? Both of them are same. That means on
Yes,
your
sir.
small q, this is your small q, there is one force acting in this direction, and there is another force which is acting in this direction. This one is your F naught, this one is also your F naught, and you know from vectors when two forces are at the same direction, this is your F
Resultant
resultant
is-
by the Pythagoras theorem. I can write F resultant will be equal to your under root of your, this one will become for me F1 square plus of your F2 square plus 2 times of your F2 into cos theta. So what is an angle between these two, beta? Theta is equals to 90 degrees, and this is the direction made by this one, that is nothing but alpha. So that is equals to under root of your F1 square is nothing but of your F naught square plus of your F naught square plus this is 2 into F naught into cos 90. Cos 90 is how much, beta? 0. So this will become for me
Yes.
0 totally. So this will become how much for me, beta? F naught square plus F naught square is 2F naught. So this will become for me root 2 times of your F naught. So this is the resultant force. Can I write? Agreed?
Yes, sir.
Resultant force, how much I'm getting? 2 root times of your F naught. Now tell me direction, beta. Tan alpha will be equal to how much? Tan alpha is equals to your F2 into your sine theta divided by your F1 plus of your F2 into your cos theta. F2 is how much for me? F naught into sine of your 90 divided by, this one is your F naught plus F naught into cos of your 90. Cos 90 is how much, beta? 0. Sine 90 is how much, beta? 1. So
Yes.
F naught and F naught will get cancelled. So this will be equal to F naught divided by F naught. F naught will get cancelled 1. So this is your tan alpha. Tan alpha is equals to 1 means alpha will be equal to how much, beta? 45 degrees. Is that clear?
Yes, sir.
So at an angle of 45 degrees, it is resultant. And what is the resultant of that one? What I am getting, better? The R resultant is equals to root 2 times of your F naught part of relation. And the direction we are getting as alpha is equals to 45 degrees from the formula. What is the formula you are using? Tan alpha is equals to your F2 into your sine theta divided by your F1 plus of your F2 into your cos theta part. Is there any doubt in this one, beta?
No, sir.
Is it clear?
Clear, sir.
Okay.
Yes, sir.
Shall I go for the next model again?
Yes, sir.
Let's see. one more question. So this, I hope you got an idea right now. So in this one only, I'm taking one more model. Same question, number B. Okay. Now what is this beta? This is a square, and we are having a charges here beta. One charge here, one charge here, one charge here, and one charge here. And this one is say for example 4q. This one is say for example 2q. This one is say small q, and this one is 2 times of capital Q. And the distances between them is given beta. This distance is root 2 times of d, and this distance is also root 2 times of your d. Okay, and this
Yes.
is the distance of this side is this much, and this side is this much. Both the sides are same, means obviously that will be your square.
Yes.
Again, question is same. What is the question? What is the question? Find the net electric force on the charge of your small cube in the following case part of relation. That means on the small cube we need to calculate the force. Now think twice. On the small cube, who are exerting the force? You give me an idea.
So 2q is exerting, both the 2q's are exerting, sir.
Hmm?
And 4q is also exerting, right, sir?
Yeah, 4q is also exerting and diagonally.
It's diagonal, it's not.
Fine, got it?
Yes, sir.
Can I say
Exactly.
that?
Yes, sir.
Can I say that there is a force now exerting even on this one like this?
Yes, sir. We can. Yes, sir.
Direction,
Yes, sir.
isn't it? And there is a force exerted even by this one in this direction right now. This is also exerting the force right now here, beta.
Yes,
This
sir.
is also exerting the force in this direction. And this 2q is also exerting the force on this direction.
Yes. Sir.
Isn't it? In this direction it is exerting. Isn't it? So now can
Yes.
I say that? Now see this one carefully. This is a force exerted by your 2q in this direction, beta. There is also force exerted by 2q. And see 2q and small q, 2q and small q are same. That means forces should also be the same, beta, no doubt.
Yes, sir.
So let us see, I'm telling you right now at a point of this one. Say for example, this is a point right now for this one. So due to the force, I'm telling this 2q, I'm giving the namings for this one beta. Like say this is your A, and this one is say for example B, and this is your C, and this is your D. Force exerted by your A on B is say for example F1. Okay na?
Okay, sir.
Now force exerted by your C on your Q, B, that is say for example F2. And force exerted by D on B will be equal to on this one, say for example F3. Totally 3 forces are acting.
Yes, sir.
Now tell me what is the value of F1 beta? F1 value will be equal to your 1 by 4 pi epsilon naught into, this is 2 times of capital Q into small q divided by, distance will be equal to how much between A
Under
and
root
B?
of.
Root 2 into D whole square.
Yes, sir. 100.
So that will become how much for me? 1 by 4 pi into your epsilon naught into, this will be capital Q small q divided by D square. So that will be equal to your F naught beta, because root 2 square is nothing but 2. Above 2 and below 2 will get cancelled there. Okay now?
Yes, sir.
The same way F2 will be equal to how much beta? F2 is also same now. It is 1 by 4 pi epsilon naught into, this is 2 times of capital Q into small q. Distance it is between them is root 2D into your whole square. That is also equal to your F naught. So both F1 and F2 are same beta. F1 and F2 will be equal to your F naught. Avana?
Yes, sir. Yes, sir.
Now tell me what is the value of your F3. Now you think and tell me the value of your F3. F3 value will be equal to how much? I'm doing right now here, you see. F3 value will be equal to your 1
So it will
by...
be the resultant of this, right, sir? It will be the resultant of F1 and F2, right, sir?
Yeah, we can even get, but still first I'm trying to calculate this one right now. This one is 4 times of capital Q into your small q divided by, distance between D and B will be equal to how much beta?
Sir, it will be, yes, sir. Under root of 2 square, 2 square D plus 2 square D. 2 into 4, 4D only, sir. It is. 4D, sir.
4 చూడు అండర్ రూట్ లో
Under root
ఉంటుంది
of,
కదా.
okay, under root of under root. Yes.
2D.
Sir, 2A వస్తుంది, sir. 2D వస్తుంది.
2D కదా.
Yes, sir.
So this will become for me how much? 2D into whole square. 2 square is 4 and this is 4. This is also coming out for me how much beta? F naught.
Yes, sir.
Now see this one carefully. So if I am saying this one as of your point charge Q beta, on this one there is one force. On this one there is one force. On this one there is one force.
Yes, sir.
Okay, this one is F3, this one is F1, and this one is your F2. See here, F1 and F2 are perpendicular to each other, beta. So resultant of this one will become how much for me? Root 2 times of F0.
Yes,
Because
sir.
angle between F1 and F2 is how much for me? 90 degrees. Kada?
Sir, yes.
If the angle between them is 90 degrees, resultant of that one will become how much for me, beta? Resultant of that one will become how much for me? 90 degrees. This one is your 90 degrees. Ardhamainda?
Yes, sir.
Should F1 and F2 one both of them are same. FR how much I got? Root 2 times of F0, na?
Yes, sir.
Now what will be the F net, beta? Can you tell me? F net will be equal to how much for me? F net will be equal to your net force will be equal to root 2 times of F0 plus of your F3. That is equals to root 2 times of your F0 plus F3 value is also equal to F0. That means that will become for me root 2 plus of your 1 into your F0. Is that clear?
Yes, sir. Yes, sir.
So that will be equal to how much for me? Root 2 plus of your 1 into this one will become how much for me? 1 by 4 pi epsilon naught into capital Q small q divided by your d square between them. And the resultant force I can write that F net will be equal to your 1 by 4 pi epsilon naught into capital Q small q divided by your d square into root 2 plus of your 1. If he's asking in terms of your capital Q and small q, this will be your answer. Can you tell me the direction of this one, beta? Direction of this one is in which direction, beta? D to B?
Sir,
Along
yes,
your
sir.
along your DB. In the direction
Yes,
of
sir.
D to B only, na, the resultant is there.
Yes, sir. That's the resultant. Yes, sir.
Okay, na? Got
Okay,
it?
sir. Yes, sir. Once, can you just show the solution, sir? I just.
Hmm?
Can you show the solution, sir? I just wanted to see that.
Yeah.
Yes, sir. 1 minute. Yes, sir.
Okay. Na?
Yes.
So, give one small note, beta. This formula you should know. Sum of your natural numbers formula in the na? Sum of your natural numbers. It is 1 plus 2 plus 3 plus 4 plus so on up to the n number if I am going.
And
Summation
yes,
of this n value will be equal to your n into n plus 1 divided by your
2. Yes, sir.
okay now.
Yes, sir.
Keep in mind this is type of equation solutions. And I hope you also know the arithmetic progression and geometric progression solution better. Good to know.
Yes. Yes, sir.
Arithmetic progression, geometric progressions. Okay now.
Okay, sir.
So I'll try to do it whenever it comes. But right now, remember, sum of your n natural numbers is represented by your n into n plus 1 divided by 2 part of relation. Okay. Now let us try to go for your equilibrium of your charges concept. Okay. Next one is equilibrium of charges. Equilibrium of your charges. So tell me when it will be in equilibrium, Nana? Whenever the net force acting on the system is 0.
Same. Yes, sir. 0. Yes.
Isn't it? If net
Yes.
force is equals to 0, then the system is said to be in equilibrium.
Equilibrium.
Say that the system is in equilibrium. The system is in equilibrium if net force is 0. Net force is 0. That means sum of all the forces acting on this one, F1 plus F2 plus F3 plus whatever the forces we are having, that all forces must be equal to 0. Okay now?
Yes.
Now say for two forces, isn't it? For two forces, for an equilibrium, F1 plus F2 must be equal to 0. That means
Yes,
F1
sir.
must be equal to minus of your F2 beta. Then only there will be an equilibrium.
Yes, sir.
If two systems are in equilibrium, F1 must be exactly equal and opposite to your F2 in opposite direction.
Yes, sir.
So for a system to be in equilibrium, the net force must be equal to 0. Is that clear?
Yes, sir. Yes, sir.
Let me tell you with the help of numericals, so we'll get a much clear-cut idea. See this question right now. Say for example, if I'm telling you, we got 2-point charges. We got 2-point charges of capital Q and 16 times of your capital Q, which are being fixed at a separation of, your D. Okay, now the question is, where should a third point charge be placed between them so it experiences no force, that is in equilibrium. Hona?
Yes.
This is your question. Now read the question. We got 2-point charges. What do you mean by point charges, beta? Whose magnitude is equals to 1.
1. Yes.
Isn't it? The point charge means, like, say for example, if I'm talking about Usmania Medical College and AIMS New Delhi.
Yes, sir.
With respect to the distance, isn't it? Both
Yes,
of them
sir.
are like point objects.
Yes, sir.
Because the distance between Hyderabad Usmania and New Delhi AIMS is right now around 1,000 kilometers roughly.
Yes, sir.
Or more than that, 1,200 kilometers, I don't know. But say
Yes.
if it is 1,000 kilometers, your campus might be somewhere around like 2 kilometers or 3 kilometers. Hyderabad Usmania
Yes,
campus is within the range of like 2 kilometers or 1 kilometers in Koti.
Yes, sir.
Isn't it? In 1,200, 2 kilometers is what? Very less value, negligible.
Yes, sir. Very less. Yes.
So I can say that is a point object. With respect to the distance,
Okay,
right now,
yes,
Usmania Medical College and All India Institute of Medical Sciences of New Delhi, they will become right now for me what? Point masses. With respect
Point.
to
Because it's very negligible.
very large distance. But if you are staying in Usmania Medical College, you will be the point mass with respect to the campus.
Usmania Medical. Yes, sir.
Have you got it? That is what exactly point mass. Point
Yes,
mass
sir.
means whose magnitude is equals to 1. And if I am talking about
Very
point
negligible.
charges with respect to distance, they are called as of your point charges. Is that clear? Now see the
Yes.
question carefully. What is the question right now? We got the 2-point charges. One is right now here, right now, somewhere capital Q. And here there is right now one more charge, that is nothing but 16 times of Q. Distance between them are being fixed, and that is equals to how much for me or D? The distance between them is equals to your D. Isn't it? Now, where should a third point charge should be kept? Where should be a third point charge be placed between them so that it experiences no force? That means somewhere in between them I'm keeping. I don't know where I need to keep. Say somewhere I'm keeping here. That I'm giving a name for this one, small q. Like say from capital Q, if it is a distance of your x, then from capital 16Q, this will become for me how much better? D minus of x.
Yes, sir.
Isn't it? Now, as the net force between them is right now for me 0, so the force on your small q due to capital Q will be equal to how much? Say for example F1. So F1 is equals to your 1 by 4 pi into your epsilon naught into capital Q into small q. Distance between them is x square. This is towards which side, beta? Can you tell me? Towards your right side.
Yes, sir.
The capital Q is exerting the force on this one.
Yes.
So I can say right now, I'm writing with red pen to do. So this is exerting the force right now here. So this is your F1 here. Is it clear?
Yes, sir.
Now if I'm talking about F2, beta, F2 is equals to 1 by 4 pi epsilon naught into one force is capital Q, 16Q, another one is small q. Distance between them is D minus of x whole square. And this 16Q is exerting the force on your small q in this direction, beta. negative x direction. So this is your F2. So this will be towards what beta? Towards leftwards, towards left side.
Yes, sir.
Have you got my point?
Yes, sir. Got it.
Isn't it? Now, in order for both of them to become zero, the magnitude of the net force must be equal to how much beta? They are already equal and opposite. Now the direction you see right now. So for them to be in equilibrium, F1 and F2 to be in equilibrium, the net force on the Q must be equal to zero. When it will become zero, beta, the net force will become zero. Net force on your Q is zero when beta? When F1 is equal to your F2. Minus sign indicates only direction. That direction already I'm taken in the diagram. Now see here I told you F1 must be equal to minus of F2. In the diagram you see F1 is minus of F2 only, na?
Yes, sir.
One is towards right,
Yes,
another is
sir.
towards left. Direction this is already the direction I have given in the diagram for you. F1 is in positive, F2 is in the negative x-axis then. Okay now?
Yes.
Now F1 value substitute here beta. It is 1 by 4 pi over epsilon naught into capital Q into small q divided by x square is equals to, this will be 1 by 4 pi epsilon naught into, this is 16 times of capital Q into small q divided by your d minus of your x whole square. Anything is getting cancelled. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, capital Q, small q will get cancelled. So remaining is what beta? 1 by x square. So it is just calculation now. 1 by x square is equals to 1 by d minus of your x whole square. Is it clear? Now taking the
Yes,
square roots
sir.
on
Yes.
both the sides. Take the square roots on both the sides beta. Take square roots on both sides. So this will become for me how much beta? 1 by x will be equal to 1 by d minus x beta. D minus
Yes.
16 kada ikkada, sorry. This is 16 kabatti this will become for me 4. Ante kada ikkada 16 is left na, sorry.
Yes, sir. Yes, sir.
This is 16. Square root
Removing this
తీసుకుంటే that will
one.
become for me 4. Isn't it? So this will become
Yes,
for me how much
sir.
beta? D minus of your x will be equal to 4 times of x. Minus x it will go here right now. This will become for me 5 times of your x. That means x value will become how much for me beta? X value will become for me your d by 5. X is equals to d by 5. From where beta? From your which charge? Capital Q.
Okay. Yes.
From capital Q, what is the value of the small gate? What point it should be kept? Means it should be kept a distance of how much beta? D by 5. From 16Q, it will be, from 16Q, it will be d minus 6. So that will be equal to d minus 6 is nothing but d by 5. So 1 minus 1 by 5 is how much beta? 4 by 5.
4 by 5.
4d by 5. From where beta? From 16Q. Here he may
Yes.
ask you anything. He may ask you from capital Q what is the distance of that neutral point or equilibrium point, or from 16Q what is that point, means you should give me the answers like this. I hope you got right now for this one.
Yes, sir. Got
Is
it.
equilibrium problems ilane cheyali manam. Idea undi kada, and we get a lot
Yes.
of questions like that. Initially it will be little bit tough, but once you go on practice it will become for me easy. So I hope you got an idea how to do
Okay,
the
sir.
problem related to this one.
Yes. Sir.
Got it now? Sure.
Yes, sir.
I'm giving you a question as a homework for you. You please try to do this one on your own. Same question like in previous one. In the previous problem, if we replace capital Q by minus Q, okay, where should, very important beta, where should the third charge be placed on the line joining the charges, so that it is in equilibrium. Okay.
Yes. Sir.
Logically, you think better. If one is negative, one is positive. One is negative and one is positive part of relation. Do you think
Yes.
that the third charge can be present in between them, beta?
No, sir, because they'll attract, right, sir?
They will attract right now, isn't it?
Yes,
So
sir.
here right now both of them are positive positive. That is the reason we could able to comfortably keep one charge between them. But if
One.
one is
Yes.
negative, one is positive, and if we keep the third charge in between them, the third charge will be again of q. So one may attract, another may repel. Then they'll be never be in equilibrium. Anna kada?
Yes. Yes. Sir.
Anna kada? So that means the third charge q cannot be placed between the charges. One thing is very clear, because the force on the small q due to the minus q and capital Q will be the in the same direction. అవునా కదా?
Yes, sir.
That means they'll get added up. Now you just think of right now, you keep a small q in between them, isn't it? Capital Q will get capital Q will try to attract the small q in towards the negative x-axis.
Yes, sir.
That means, like say, capital Q is having more power, small q is having smaller power. So smaller power is smaller body is having a tendency to move towards the capital Q, or capital Q is having tendency to move to the small q.
So the capital Q, sir.
Anna, just what I am trying to tell you is this one. See, this one is capital Q.
Yes,
This one
sir.
is 16 q. And this one is
Yes, sir.
negative. And here is right now minus.
Yes, sir.
Now see,
So the capital
this
Q
is
only will
minus,
move.
this is positive. Force is always from which side to which side, beta? Force is always from which side to which side? Now tell me, what about 16q? 16q will exert the force on small q, so that will be the force in
Yes,
this
sir.
direction. This is, say, for example, force due to the 16q. Now force due to
This
minus
is
q is also in
negative,
the
sir.
same direction.
Same
Force
direction,
due to
negative, sir.
minus q is also in the same direction. So they are getting added up, brother.
Yes, sir.
So when two bodies are getting added up in the same direction, will they become zero at any time?
Yes, sir. No, sir, they won't.
They will not become zero, brother, because they are both of
They
them are
never
getting
have it.
added up.
Yes, sir.
They will become zero only if they are adding in the opposite direction. That is the
Opposite
reason
direction.
the small charge cannot be kept in between your minus q and
Yes,
capital
sir.
Q. Okay, now?
Okay, sir.
That logic clear?
Yes, sir. Yes.
Using that logic, you try to do the problem. You try to do in on your own today. If you are not getting, I'll try to help you out in the tomorrow session of your class. Is that clear for you?
Okay, sir.
Am I doubt on the intro? How shall I do it now?
Got it, sir.
What it
We'll
now?
try this, sir. Yes, sir.
You can just try it out. If you're not getting, you please let me know. I'll try to help you out with that one. Okay, now?
Yes, sir.
Next problem. So that was about the story about an equilibrium. Still, we have lot number of numericals to do. But once you got an idea, you try to do this one on your own. Then our remaining models also, I'll try to do it in the tomorrow session of your class. Okay, na?
Okay, sir. Yes, sir.
Now let us try to go for the next one. That one is problems related to the strings. Concept of problems related to strings. Then Newton's laws of motion apply. We are applying the concept of your Newton's laws of your motion. Okay, now?
Yes.
Sure. See this one. Okay.
Okay, sir.
This is some support better. And here we are having two charges kept at here right now somewhere. Here there is a charge of Q and mass of your M. This is also a charge of Q and mass of your M. So obviously there will be what beta in between them? What type of a force will exist between them? Both of them are positive, positive.
They'll repel,
Them are
sir.
positive and positive. So what type of the force will exist between them? Repulsive force
So
exists.
repulsive. Yes, sir.
Positive and positive, there will be a repulsive, isn't it?
Yes,
And it is making here an
yes.
angle, say for example theta, and here also it is making an angle of your theta. Okay, na? Now see,
Okay.
the balls are right now. So we are taking the two identical balls, beta. Two identical balls, each having a charge of how much for me? Q and mass of your M, and they are suspended from the common point by the two insulating strings, beta. Length of the each string is capital L, and the balls are in equilibrium, beta. The balls are in equilibrium. So the balls are
Yes.
in equilibrium means if I take one string into the consideration, beta. So the forces acting on this string you see right now. One is the weight of the body acts in the downward direction, beta. Weight of the body, that is nothing but of your mg, isn't it? So there will be a tension in the string which is acting here right now. So this will be the tension, that is nothing but of equal to T. So if I resolve this T into the components right now in equilibrium, this is your theta. Here this will become for me T into cos theta, and this side here this will become for me T into your sin theta. Is it clear? Is it clear?
Yes, sir.
Dissolving clearer, because string kabatti there will be the
Yes, sir.
tension in that one. There will be the tension in that one. So in equilibrium I can say that in equilibrium weight of the body will be equal to how much, beta? M into G, can I write? And
Yes,
force
sir.
between them will be what, beta? Electric force. There will be repulsive force between them, that will be equal to 1 by 4 pi epsilon or naught into Q, that is Q square, divided by distance between them is x square, isn't it? So this is exerting the electrostatic
Yes, sir.
force in this direction, and this is also exerting the electrostatic force in this direction, isn't it?
Yes, sir.
Now this electrostatic force is balancing what, beta? Tension in the string you see right now. Tension in the string, if I see that T sine theta is balancing right now for me. T sine theta is balancing your electrostatic force, and T cos theta is balancing the weight of the body. That is nothing but of your W. That is nothing but
Okay.
equal to your mg. So if I
Yes.
divide these two equations, beta, so this is, say for example, equation 1, and this is your equation 2. So if I am dividing 1 by your 2, that is nothing but of your T into sine theta divided by T into cos theta, that will be equal to F electric force divided by mg. Here T will get cancelled. Sine by cos will become how much, beta? Tan. So this will become how much for me, beta? Tan theta will be equal to your F electric force divided by your M into your G. Clear?
Yes.
Now, what will be the tension, beta? How do you calculate the tension between them? Because see, if you see the diagram, this T cos theta and T sin theta are perpendicular to each other, isn't it? So the T
Yes,
is
sir.
equal to how much right now for me? T will be equal to your under root of your, this will become for me T into sin theta whole square plus of your T into your cos theta whole square. Agreed?
Yes, sir.
Isn't it? So in this one, T sin theta is balancing what, beta? T sin theta is balancing your F electric force, and T cos theta is balancing your mg force. So this will be the tension in this one. Clear?
Yes, sir.
Is it clear? Now see, if I take this diagram very carefully right now, here you see, beta, I'm drawing here, you see. See, this is a part of a triangle. What half of a triangle together?
Yes, sir.
This angle is how much for me, or theta? This angle is how much for me? This distance is x by 2. This is the length of the string, that is L. So obviously this distance will become how much for me, beta? This will become for me L square minus x square divided by 4. Anna?
Yes, sir.
Now from this figure I can write tan theta value will be equal to how much, beta? X by 2 divided by, theta is above gravity. This one is here under root of your L square minus of x square divided by 4. Okay?
Yes, sir.
Theta is very small. If theta is very small, tan theta can be approximated to sin theta. This is the trigonometry which you should know. If theta is very small,
Yes,
tan theta is approximated to sin theta. So sin theta will become how much for me, beta? X by 2 divided by L. Clear?
Yes.
This is the basic knowledge you should have. If theta is very large, like if it is 30 degrees, 45 degrees, 60 degrees, use this one. If theta is say like 10 degree, 5 degree, 2 degree, then we'll be using in the place of tan theta, sin theta. So sin theta will become for me x by 2 pi or L part of relation. So whenever you are solving the problems related to strings, this is the basic way how you approach the problem. I hope you got rough an idea how to do the problems related to the strings. First thing is in equilibrium, you should balance the forces acting in the vertical direction or horizontal direction. As the charge is having a mass m, so weight of that body will be acting in the downward direction. So this will be equal to the weight, and tension T is acting to along the string cavity, that is making an angle theta. So resolve the force in the horizontal component and vertical component. Horizontal component is T sin theta, vertical component is cos theta. You know that wherever is theta, that side will become for me cos theta part deflation. And as there are the charges and of having equal magnitude and same nature, that is the reason there will be a repulsive force. So F electric force is acting in opposite direction. So F electric is balancing T sin theta and weight mg is balancing your cos theta. So from that relation, if I am taking right now, dividing this relation, T sin theta is balancing electric force, T cos theta is balancing the weight. So I'm getting the angle between made by that one as of your tan theta is equals to your electric force divided by your mg. And tension acting in that one is calculated by the formula. T is equals to your directly tension is given, angle is given. I can use this formula. Or if electric force is being given, the tension in terms of weight can be calculated by this formula part relation. If angle is not given, if angle is 30 degrees, 40 degrees, I can use this formula. Tan theta is equals to your x by 2 divided by under root of L square minus of your x square divided by 4. If theta is very, very small, then we'll use the tan theta is equals to sin theta approximation. So sin theta is equals to x by 2 divided by your L part. Is that clear?
Yes, sir.
So we'll try to do some problems based upon this one in tomorrow's section of your class. I hope you got some clarity related to the equilibrium of your charges and how do you calculate the basic related number of your problems related to this one. Is that clear, beta?
Yes, sir. Yes, sir.
No doubt on the chapter. I'll try to help you out.
Got it, sir.
Yeah, sure. Okay. Take care, beta.
Yes.
Bye.
Thank you, sir. Bye, sir.